Welcome, future scientists, to ScideoCast, where we podcast scientific issues along with visuals, so you won't be listening to an educational audiobook, but you'll be doing some interactive learning instead.
I'm your host Minty, and in today's episode 2, we'll talk about the effect of ocean acidification on the marine life and the environment. Today I'm joined with my co-host Jacob, who will help me explain ocean acidification better.
Since the birth of the Industrial Revolution in the 1950s, humans have been able to utilize fossil fuels for their convenience. Since the burning of fossil fuels releases CO2 into the atmosphere, it causes sea temperatures to rise. This leaves a devastating impact on marine biodiversity. This is known as ocean acidification. With the chaotic consequences of climate change upon us, is it too late to reverse the effects of ocean acidification?
Fossil fuel has been used by humans since the industrial time. It can be in the form of heat, electricity, and the creation of products for convenience of life. This, however, causes CO2, a byproduct of burning fossil fuels, to be released into the atmosphere in masses, which has led to a global warming effect.
Global warming is when UV rays from the sun pass through the atmosphere and heat up the surface. The surface then reflects heat back into space in the form of infrared. CO2 absorbs the infrared and gains kinetic energy. It then passes this heat onto molecules like hydrogen and oxygen, heating up the atmosphere. Acting like a greenhouse, these gases block infrared radiation from going back into the atmosphere. This is known as the greenhouse effect.
The ocean is always at equilibrium, with the same amount of bicarbonate and carbonate. But when a lot of carbon dioxide is dissolved into the ocean, it forms carbonic acid. Carbonic acid dissociates and forms bicarbonate, carbonate, and hydrogen ions. Increase in hydrogen ion causes the pH to drop. Decrease in carbonate leads to a decreased rate of calcification, where shells use carbonate to make calcium carbonate, which stores carbon dioxide. Shells dissolve at around 200 millimoles of carbonate ions per kilograms of water. As they dissolve, they release carbon dioxide gas into the atmosphere, contributing to a runaway effect. Data from Coastal Adapt shows an approximate level of carbon dioxide dissolved in the ocean. Extrapolating from this data, we can estimate that in 2018, the amount of carbon dioxide dissolved into the ocean is around 375 ppm. Now we'll have Professor Definitely Not Jacob demonstrating how carbon dioxide acidifies the ocean using pH testing kit and SodaStream.
We're going to test the pH of water. Here we have SodaStream machine, 2 water that will be testing. Test tube, pH indicator, and a pH chart. First, I'm going to take a sample of normal water. Now, I'm going to get a sample of normal water and carbonated. Then I'm going to take a sample of that. And put that there. First we'll test the normal water. Three drops. Put that there. You can see that the pH is neutral. Now we're going to test the pH of carbonated water. And we can see that the pH dropped to around 6.
I've just gone and picked up some shells here from the beach. Now shells are made up of calcium carbonate. This snail shell here is starting to slightly dissolve here at the top, and this shell over here is starting to gradually peel off in layers. These are the effects of ocean acidification. So it's caused by the increased hydrogen ions in the ocean. It decreases the pH, and basically that causes them to dissolve and release CO2 back into the ocean.
Global warming has caused damages on the coral reef. When the Earth's overall temperature increases, the ocean's temperature also increases. When temperature increases, coral expels their zooxanthellae that provides them with glucose and color. When there is no presence of this photosynthetic partner, the coral loses its color, creating a coral bleaching effect.
Now we'll have coral biologist Tracy Amesworth examining coral with a laser microscope.
What we wanted to do is look at what normal healthy tissue looks like and then to see just how damaged the coral tissues have been from the bleaching event.
When healthy, each square centimetre of coral tissue is packed with around 2 million algal cells.
So if we look here at normal healthy tissue and then compare that to the bleached tissue, all the symbionts are gone. You're not seeing any of the red cells within the tissue.
The glucose is used to sustain the coral's growth and development, as well as provide the biodiversity with food. Without glucose, coral will stop developing and die. Therefore, biodiversities that feed on the corals will lose their food source and shelter. Eventually, they will also die. This in turn affects the whole food web, as some species will go extinct in the food web. And eventually, this will affect the human food source as well.
Coccolithophores are an essential species that maintain the regulation of the ocean's temperature. They are tiny phytoplankton that produce tiny, beautiful calcium carbonate shells. They form massive, white ocean blooms that can reflect sunlight and keep the ocean constantly cool. This is called the albedo effect. Coccolithophores also make smart gel that are made up from carbohydrates, proteins, and 10 to 15% of their fixed carbon dioxide. This gel forms cloud nucleating particles so that water particles can attract to it and make clouds. When temperatures are high and pH is low, these nuclei shrink to less than 200 nanometers and become airborne through the wave movements. When the temperature cools, the nuclei swell and cannot be airborne. Therefore, clouds cannot be made. The rise in ocean acidity causes an increase in nucleating particles to shrink, and more clouds are made. Of course, this would result in the cloud albedo effect, which reflects the sun's heat off the Earth's surface. However, with rapid cooling temperature, the particles swell and cannot become airborne. Less nucleating particles will be made, and the sun will directly hit Earth with minimal heat reflections. With the irregular patterns of cloud production, humans would have to face extreme weather patterns and even natural disasters. Coccolithophores are also responsible for 50% of the world's photosynthesis. When the ocean becomes more acidic, the coccolithophores dissolve their shells, which make it harder for them to photosynthesize, as they exert more energy to repair their shells. But when the shells dissolve, it releases even more carbon dioxide, which further acidifies the ocean. The chance of them dying is likely. When that happens, it will lead to a cascading effect on the environment. As the world's photosynthesis rate decreases, cloud nucleating particles wouldn't be able to make as many clouds as they used to. Phytoplankton are also at the bottom of the food chain. Therefore, if they die, the next trophic level would also die, creating a continuous effect on the food chain.
As the level of carbon dioxide rises, the ocean becomes more acidic with increasing concentration of hydrogen ions, causing crustacean shells to dissolve. When shells dissolve, they further release carbon dioxide back into the ocean and to the atmosphere. This becomes a vicious cycle. Since crustaceans mostly focus their energy on repairing their shells, they become weaker and reproduce at a slower rate.
Eventually, these become extinct.
This in turn affects the food web and finally to humans, as we will eventually deplete our seafood options.
Ocean acidification is caused by the massive increase in carbon dioxide emitted into the atmosphere and absorbed into our oceans. It leaves a devastating impact on coral reefs, phytoplankton like coccolithophores, and crustaceans.
If you want to reduce the effect of ocean acidification and have hopes to save the environment, you should stop using fossil fuel and switch to biofuel. We should increase conservation efforts for coral reefs and urge the governments and organizations to take actions by supporting eco-friendly companies. We could use less unnecessary products, recycling more, and switching to renewable and sustainable fuels, products, and practices. We should use fewer cars and take more public transport. And it saves your wallet as well. Alternatively, if you want to save money and get some exercise at the same time, ride the bike. Tune in next time, where we'll discuss the permanent extinction and how we could be heading towards the sixth extinction.